Welcome to our webinar, Navigation in an Era of Escalating GNSS Interference, hosted by infiniDome. I'm Tamir, Eshel, the editor and publisher of DefenseUpdate.com, a publication that has been following defense technology innovation since the 1970s. And today we are covering GNSS and electronic warfare in modern warfare as well. Thank you for joining us today. This webinar is relevant for developers, manufacturers, and system operators relying on position navigation and timing services for their operation, services that have been adversely affected by recent conflicts. GNSS interference is a serious issue affecting many users worldwide, and we appreciate you gathering with us today to discuss this important topic. I'd like to share with you the agenda today. In this webinar, we shall discuss the following issues. Who should be concerned about GNSS interference and why? What challenges do we face? And how can we deal with those challenges? In the next hour, we shall deal with those questions from different angles. We'll learn from industry experts about the scope and the problems and the manifestation in and around major war zones, primarily the Eastern European and Middle East regions. We will also be able to explore how infiniDome's anti-jam techniques overcome GNSS interference. And after the presentations, we will provide ample time to address your questions. Before we begin, please note that you can submit your questions anytime using the Q&A button on the bottom of your screen. We'll address these questions during our dedicated Q&A session. This webinar is being recorded and will be available on demand on infiniDome's digital channels. So let's proceed with the presentations. With me today are Omer Sharar, infiniDome's Chief Executive Officer, Dana A. Goward, President of Resilient Navigation and Timing Foundation, Jeff McAllister, President of Printed Aerospace, and Ofer Rubin, Heven Drone's Chief Technology Officer. Sorry. Let's start with the presentations. I invite Omer Sharar, Chief Executive Officer of infiniDome, for the opening presentation.
Thank you very much, Tamir, and it's an honor to be here with you, Tamir, with you, Dana, Jeff, and Ofer. Really great to have this opportunity to talk, and thank you everybody who joined us for this interesting session. So as Tamir mentioned, I'm Omer. I'm co-founder and CEO of infiniDome. If we can, Noam, can we start with a short video? Thank you. So let me now move to my presentation. 1 second. So I always say that although, unlike Jeff and Ofer, at infiniDome, we don't make these awesome platforms. But we make sure that these awesome platforms can reach their target, and we try to make sure that they can stay in the air. So that's why this video comes to basically show what types of platforms we are currently concerned with when facing these types of interferences. I want to start by just talking a little bit about GPS. We all know GPS, we all use GPS, we all use it to get from point A to point B, probably every day on work, to go and to come back from work. But a little bit about GPS. GPS is, or GNSS, is by far the most vulnerable signal we can't live without. All in all, we're talking about GPS, which is the American constellation. But like GPS, we have GLONASS, the Russian constellation. We have Galileo, the European constellation, Beidou, the Chinese constellation. All in all, we're talking roughly about 100 satellites orbiting Earth at 20,000 kilometers above ground level. Now, the signal that we receive here on Earth, whether it's by our phones, by our drones, by our vehicles, by our tanks, it's all the same strength of signals. And it's all about the equivalent as if you take a 20-watt light bulb, light it up in Berlin, and try to receive its light in Tel Aviv. That's about how weak GPS is when it reaches our receivers here. Now, all one has to do to interfere with that signal is to transmit something, anything really, a little bit more powerful than that very weak signal that I told you about. And the problem is that all of the GNSS band is constant. It's called the L band. It's known frequencies. So it's very easy to do. Now, we're viewing today two major threats. One is jamming, which was very prevalent even before Ukraine and October 7th war here in Israel. But another one is spoofing, that since the beginning of the war, at least here in Israel, we're seeing it more and more popular and more critical to be able to cope with. Jamming is the equivalent in the cyber world of a denial of service attack. It's blocking the GPS signal, basically not allowing the receiver to be able to get a lock on that signal. Spoofing, however, is the equivalent in the cyber world of hacking. It's feeding your receiver with wrong data and making it be locked onto that bad signal and feeding it with bad information of position or of time, both of which can be very, very problematic to be able to execute your mission. Now, how can these things be interfered with? I have here a few examples. The first one in the middle, you can see a handheld jammer. You can buy these things, unfortunately, online for 20, 30 bucks on the average Chinese website, unfortunately. And these things, you'll be surprised. You can reach your home post office, you click a little button, you turn this thing on, and it kills every GPS receiver within about 100 meters. You can make that a lot more effective using off-the-shelf amplifiers and a directional antenna. And here you have a great counter UAV weapon that can down drones from several hundred of meters away. On the right side, you can see a more popular military-grade handheld directional jammer. These are tactical jammers that are used to down drones from up to a kilometer away, maybe even several kilometers. And on the leftmost side, you see a high-powered, multiple kilowatts jammer, EW jammer, most likely all of the GNSS bands, used by countries like Russia, for example, to basically be able to cripple GPS reception in, well, almost an entire country. I have here a very interesting example. This is from a website that is available to all. I welcome everybody to log on to it. It's called gpsjam.org. What I did is I tried to see, can we look at some kind of jamming trend before a war starts? So on the left side, you can actually see a month-by-month evolvement of high-power GPS jamming in and around Israel before October 7th war. And as you can see, we always had GPS problems in this area. But towards October 7th war, we're seeing it getting worse and worse and worse, even before the war started. On the right side, you see an equivalent picture in Ukraine. From the beginning of 22, when the war started, GPS jamming was not that powerful and not that frequent. And towards the back end of 22, we're seeing that GPS jamming got more and more powerful and more effective, not only in Ukraine, but around Ukraine as well. Now, this is GNSS attacks in October of this year. You can see that now this is data, by the way, collected from ADS-B information from airplanes high in the air. But this is a very good indication of what's going on right now in the field. And as you can see, it doesn't only stop in Ukraine or in Israel. We're seeing that countries like Romania, Poland, Germany, Latvia, Estonia, Finland, Norway, and other countries are being affected by high power jamming probably originated from Russia. Now, this is for the viewers back home. Can you guess which region is this? This is Taiwan. This is, as we are seeing, the heated space of GNSS interference from China towards Taiwan. So I think that everybody can agree that since the war in Ukraine started and the October 7th war in Israel started, we are seeing that the battlefield has changed. It's no longer a game of high capable, very expensive $30 million Reapers or very expensive, highly capable UAVs. We're seeing that the name of the game is smaller, lighter, cheaper UAVs that you can build them in masses, deploy them quickly, improve them, understand what needs to get better, improve them, and repeat. And there are many programs around the world, in the US, in Israel, in Europe, in India, in Korea, that all go to that effect, calling for the industry to make cheap or relatively cheaper drones that can be built in masses and can be deployed quickly. But there is one thing that I call one-to-many capability, which is critical to make this effective. The one-to-many capability basically means that one operator can control potentially an army of drones. If that one-to-many capability does not work, meaning that the UAV platforms do not have that independence and that capability to navigate on its own, then that one-to-many capability doesn't exist. And beyond visual line of sight capability is not enough. You need autonomous capabilities, you need swarming capabilities. And for these capabilities to become a reality, you need navigation resiliency. So we are seeing that in these battlefields, what used to be game-changing weapons, like the thousands of drones that Ukrainians have built, whipped up and bought and were able to launch, and were really caught Russia by surprise in the beginning, the Russians caught up to their EW, their electronic warfare game, and started downing drones by the thousands. More than 10,000 drones have been downed monthly in Ukraine. And we're seeing that, again, game-changing weapons like GPS-guided bombs, like the JDAMs, like the Gimblers, the guided multi-launching rocket systems. Again, amazing weapons that literally were war tipping points are not as effective as they should be because of these GPS jamming problems. Here in Israel, and we're going to talk a little bit about this in a little while, IDF itself has been using GPS jamming and spoofing capabilities to cripple GPS-guided anything by the Iranians, by the Hezbollah, by Hamas. And what that resulted in is that IDF drones are, again, without protection, are suffering a lot from these types of interferences. But not only military applications, we're seeing that precise agriculture uses GPS for centimeter level accuracy can't operate anymore in Israel. We're seeing that marine explorations, that aerial photography, all of these types of applications don't work as well as they should or at all in the face of these jamming. So after scaring you, question is, what can be done? So I put down 4, I call it pillars of resiliency. The first pillar is looking at receiving as many signals as possible. The second pillar is try to use encrypted GPS, and I'll talk about that in a second, when possible. The third pillar is what we do at infiniDome, protect your receivers. And the final point is what we do with our partners, which is using as many layers as possible to complement, to back up, to augment GPS, and do a good job at fusing it together. So first, starting with multi-constellation, multi-band. So we all know GPS L1. We all heard it before. It's a 1575.42 megahertz signal, and we all use it everywhere. But that's not the only signal that we can get from GPS. GPS can emit other signals, L1, L2, L5. And you can work with other constellations that I told you before about. Not only GPS, but look at GLONASS, look at Beidou, look at Galileo. Today, when choosing the right receiver, try to choose a receiver that is multi-constellation, multi-band. Try to receive as many signals as you can. Try to make the best use of them. Why? Not only because it increases your capability to receive as many signals as possible, but also because sometimes only one band is being jammed. So if you can work with multiple bands, that gives you the ability to cope with a single band jamming. The second point, which is, let's say, a prerogative almost entirely of the US DoD, it's encrypted GPS. It was called SASM. Today it's called M-code. These are ITAR-controlled receivers that use encrypted GPS signals, which is, as far as I know, impossible to spoof, impossible to trick. And it's harder to jam. Not impossible, but it's harder to jam. The problem with these things is that it's ITAR controlled, as I said, even to friendly countries to the US. They're not freely given. They're very expensive receivers, and it's still very susceptible to jamming, so it doesn't solve everything. The final note, or not the final, the third pillar is what we do. Protect your receiver. You have a GPS receiver, protect it. Today, we bring to the game what we call proportional capability for GPS protection. We're using null steering capabilities, adaptive antenna capabilities in our modules that allow you basically to attenuate the attacking signal. By retrofitting, by adding a module to your existing UAV, basically take whatever receiver you have that has an antenna, disconnect the antenna, connect one of our models, GPS Dome or GPS Dome 2, connect to it 2 to 4 antennas, and you have a retrofit solution without the need to actually recertify any of your existing solutions, because that can be added on to whatever receiver you have and makes your UAV about 100x, 100 times more resilient to these types of attacks. That's not a bulletproof solution. There is no bulletproof solution in that world. So my mantra is try to use as many solutions as possible, but hey, do a good job at fusing them together. Most of our customers, no offense to anybody here, but of course, they know how to build drones in a great way. But when it comes to navigation resiliency, we try to be their trusted advisor. This is basically what we did with our partners, Honeywell. We built together with them a integrated navigation solution that we call Resilient Navigation System, which comprises of an inertial navigation capability, which backs up the ability to navigate where no signals are available. It combines our GPS anti-jamming GPS Dome or GPS Dome 2, and it combines alternative navigation capabilities using radar. The same approach could be used with video navigation. The same approach could be used using even LiDAR. The approach should contain the ability not to have a single point of failure in your product, in your platform. Now, since October 7th, we saw that IDF, and I'm at liberty to talk about this, has been using all capabilities that it can to basically cripple the ability of our enemies to shoot at us GPS-guided anything. But we're seeing that the modulations and the techniques that IDF is using is rapidly evolving. And I put here a quote that I really like from Sun Tzu's The Art of War. Those who are able to adapt to change in accord with the enemy and achieve victory are called divine. The point of which has to come and say, what I have today doesn't necessarily protect me from things that are about to come, which means that we always have to understand how can we get better at protecting, not necessarily from our enemy, as we're seeing here in Israel, but also from our own forces that are using these advanced types of modulations and techniques. So what we did at infiniDome is we basically, after the beginning of the war, we stopped R&D, we stopped almost entire operations, we spread our teams to the northern border, to the southern border, to the eastern border, and we started recording and analyzing and learning, pardon my French, but what the hell is going on in the spectrum? And we tried to understand how or what is actually changing and how can we adapt our current products and our future products to be able to cope with these new techniques and modulation that are popping out. This is basically an approach that we have introduced to all of our products today, both GPS Dome and GPS Dome 2. We call it the software-defined anti-jamming approach. The idea is that when you buy a box from us today, yes, it's a hardware module, but it has a very flexible software module. And the idea is to be able to update it when needed to be able to cope with the recent threats that we're seeing popping out in the field. And that is basically what we're doing. We're waking up every morning trying to figure out how to make our current products and our future products being able to cope with the new threats that we're seeing popping out. That's about it. Thank you.
Thank you very much, Omer. We'll hear Omer again later during the demonstration. I invite now Mr. Dana A. Goward, the president of the Resilient Navigation and Timing Foundation, to provide his market perspective. Dana, please.
Well, good morning, and I don't know if I can offer very much to what's already been said, but I'm a recovering former government bureaucrat, so I'm going to talk anyway. But we'll step through this pretty quickly. But first, let's answer the question as to who should be concerned about this. And I would say you really only need to be concerned about this if you use the internet, have a cell phone, if you really like electricity, if you travel from one place to another, and if you eat food. So if any of those things apply to you, you should be really concerned about this. So let's take a look and see what is, there we go. And why is that? What is the problem? Well, the problem is that everything, just about everything in the modern world depends upon GNSS or GPS. GPS, of course, has the biggest share because it was first to market, and that's the way those sorts of things go. But it's not just that everything depends upon GPS. It's that everything also depends on, oops, there we go. That wasn't very good, was it? Everything also depends on everything else, right? So it's all interconnected. And so you have, when GPS or GNSS fails, you have the possibility of cascading failures. And it's one of those complex, wicked problems you just never know what's going to fail next. And of course, we have a long history, as Omer mentioned, of jamming of GPS and satellite signals. And of course, there's a whole range of threats, both natural, cyber, electronic warfare. Some people are calling this a spectrum problem, but whatever the problem is, it ranges from global down to within 100 meters of what you see. So it's hard to know what's going on and when it's going on. And as a result of that, back several years ago, the European Union decided to do a sampling just to show you that this happens in a non-conflict environment and every day. Why is that? Because it's just really easy. It's really easy to do, and a lot of people have motivations to do it. So they went out and did a sampling, and they found literally hundreds of thousands of events that could or did interfere with GPS and GNSS signals. Now, interestingly, even though they found hundreds of thousands of events, they determined that only about 10% of those were malicious, were intentional. All of the rest were accidental. So it's, as Omer was saying, it's a very, very, very weak signal, and people can interfere with it. Other nature can interfere with it accidentally, and that happens a lot. So even if the world is finally at peace, everywhere, and GPS and other GNSS are working perfectly, there's going to be interference, and you need to be concerned about that if you want to depend upon it. And of course, we have seen that not only can't you depend upon it because of accidental means, but there are lots of malicious folks out there who are looking to interfere with it, as we have seen with gpsjam.org. And this isn't even really a conflict zone. At least it's not a hot conflict zone, right? This is just Vladimir Putin trying to undermine Western systems and undermine confidence in not only the systems, but the governments as well, making the world a little bit more dangerous for the rest of us. Just God bless him, right? So that's jamming and general interference. And interesting thing about jamming is you just don't know sometimes whether it's jamming or spoofing. We had a good example of that in 2019 with a commercial aircraft that almost flew into a mountain in Sun Valley, Idaho. There was some GPS interference, apparently. We assume it was accidental, and they followed the wrong signal through smoky haze. and were just about ready to impact a mountain when, fortunately, air traffic controller, some hundreds of miles away, saw what was happening and directed them back on the right course. So, and then, of course, there is, as was mentioned, spoofing. The most public, earliest incident of that was in 2011. As you can see here, there was a U.S. drone operating in Afghanistan. Somehow it ended up in Iran. Now, a lot of pundits at the time said, well, clearly it's not possible that the Iranians spoofed it over there and caused it to land. That just can't happen. Well, one, how did the drone actually end up there if that didn't happen, as the Iranians claim that they did? And two, a short time later, Professor Todd Humphreys at the University of Texas demonstrated how to spoof a drone. He flew a drone in this football stadium and then took over control of it, basically, with his own software-defined transmitter. And then, of course, shortly thereafter, at the DEF CON convention in December of 2015, this young lady from China showed everyone how to build their own spoofer in case they didn't know how already. And she was very conveniently sending small kits of parts for about $300, where you could actually follow her instructions and build them on your own. Shortly after that, the U.S. Department of Homeland Security announced that one of its border drones had been spoofed by an international criminal organization. And then the next year, we had this very interesting incident of some U.S. Navy vessels that were going to make a very simple transit you would expect from one place to another in the Middle East. And somehow they ended up not going where they should have been going. And instead of President Obama's last big public speech being the front page news, it was the fact that the Iranians had captured a couple boats full of U.S. sailors. How embarrassing. Just happened to be right after the U.S. and Iran nuclear power agreement, which many folks in the Iranian hardliner group felt was kind of an embarrassment for them. So there you go. Later on that year, Moscow announced openly, hey, we can eat your GPS for breakfast. And that, in fact, is exactly what happened as the Moscow Times was compelled to say something because folks trying to get an Uber or a Lyft in near the Kremlin to go to the airport found their receivers telling them, well, you're already at the airport. You don't need a ride. And of course, they weren't. Subsequent to that, there were a number of studies that were done. We observed a lot of GPS spoofing in the Black Sea, and you can see here where the spoofing devices were traced back to. In one instance here, you can see it was traced all the way back to Moscow. Somebody forgot to reprogram, or perhaps they just decided not to make the trip south that day. So, and this very interesting report documents that. Still a lot of good information in there, even the location of a significant Russian interference operation in Syria. And as we go on in time, without beating a dead horse too much, we find that more instances of accidental and intentional disruption. We find academics saying, well, it's not just GPS. We can spoof all of the constellations at exactly the same time for about $175 worth of parts. It's not pretty, but it works. And guess what? We can also send them a fake map, so that when they look outside and they look at the fake map and the route we're bringing them along, they won't right away figure out that something is wrong. So a lot of potential for hacking. And we move along. You all know about circle spoofing, which came up in 2019, which we've seen. This is the port of Shanghai. And then subsequent to that, we see moving all the way across the globe to circle spoofs. So clearly some folks on maritime vessels are interested in at least electronically being someplace where they very much are not. So we've seen this evolution over the years of in spoofing, and the ease of doing it, and the reduction in price and difficulty. And it's a real threat, as you know. For example, if someone wanted to hijack a maritime vessel, as was demonstrated by Professor Humphrey, relatively easy with small course changes and small information changes over a longer period of time. You can go from being on a normal course from South Africa to Japan to landing up early in pirate land. So We don't know that that's happened, but it may well have. People don't like to talk about those kinds of things. And of course, we've seen this nearly happen in the Middle East with aircraft that are spoofed. And it continues, as you know, to happen in the Baltic. And it's so common that really smart people have decided that they're going to make it into a little app so we can see exactly what's happening all over the world and how often it's going on. If you don't know this website, I highly recommend it to you. You can even zero in on the individual aircraft and get a picture of them, their flight plan, tail number, and the whole thing, all based, as mentioned, on ADS-B. So is it really something we have to worry about? Darn tootin', it's something we have to worry about. And because it's not just bad now, it's going to continue to get worse. And why is that? Because the bad guys have all kinds of motivation to keep it going. We have very few things that we can do to disrupt it and to punish the bad guys. At least that's the way it seems. And guess what? It's not going to be just from the land anymore. This is a real concern that the Chinese system Beidou, the GPS equivalent, can actually transmit GPS and Galileo signals, so acting as a giant spoofer in the sky, and that the Russians have fielded a nuclear-powered electronic warfare device that is soon to be in orbit that can just wreak havoc over large areas. So yeah, we should really be worried about this and doing everything we can to counter it. And what are those things? Well, as Omer said, we do need to protect the signals. We need to know where the interference is coming from. We need to terminate the interference when we can. We need to have much better equipment than most people have right now. Unfortunately, there's a lot of really weak equipment in both aviation and maritime, and it takes a long time to get new equipment and standards and such in there. We need to augment these signals with other kinds of signals and services so that we have a comparison and we have something to rely on when these are not available. So there you go. Thank you very much for your time, and I look forward to speaking with you more and all your questions.
Thank you, Dana. I remind you, Dana will join us later to answer your questions on the Q&A session. Let me remind you to submit your question through the Q&A button. It is located at the bottom of your screen. Let's move on. I invite Mr. Jeff McAllister, President of Printed Aerospace, to present his overview of the operational challenges encountered in Eastern Europe. Jeff, please.
Yes. Hi, thanks. Sorry, I must apologize at the beginning. I'm a little under the weather, but it's showtime and I'm going to grind through this. So I'm not a smoker, even though I sound like I had a carton today. But let me share my screen and talk to you. What I can add really in the conversation here is Omer earlier talked about some of the conflict theaters where you're seeing a lot of need. And we've been conducting business in Ukraine, and I'm going to give a little bit from my experience, some of the taste and flavor of what it's like to actually try to conduct business in a conflict theater like Ukraine. We met infiniDome in America, and we did our integration and testing with infiniDome in America and in Eastern Europe, and very impressed with the team and also their knowledge and also, just the effectiveness of their solution. Let me share my screen now, and I'm going to talk about what it's like to actually try to do business in Ukraine. As I said, one of the theaters that needs GPS protection more than anything. First of all, over my 30 years of doing business internationally, I would say doing business in Ukraine is probably the most challenging and frustrating on any place that I've ever worked in. First of all, everything about doing business in Ukraine is logistics. It's a logistics challenge to do anything, because the first thing that you're going to have to do is you're going to have to cross the border, because to do business in Ukraine, you're going to have to get to Kyiv, but no one is flying into Kyiv, of course. So when you look at how are you going to get to Kyiv, you're going to have to cross the border, and you're probably going to cross either in Poland, Slovakia, Hungary, or Romania. And you can see on the map there, the Carpathian Mountains go through southern Poland, through by Slovakia, and all the way down into Romania. So there's always challenges even in crossing the border from those NATO countries into Ukraine. And that's why the majority of people who actually try to enter Ukraine, they come through Poland. And one of the ways that you're going to get to Kyiv eventually is you got to choose how you're going to get there. You're either going to drive there or you're going to take the train. Well, I've never taken the train, so I can only talk about my own experience. And we always, to try to get to our target area of Lviv or Kyiv, we've always tried to go through Lviv. Crossing the border over there can take time. Sometimes if you're in a car and you might be waiting hours just to get across the border. I've crossed on foot, crossed in a car, and it's a lot easier actually on foot. I can get through in minutes, where sometimes it might take 3 to 4 hours just to get across the border. But then the one thing is you're going to have to drive to Kyiv. And even though it looks like a straight line on my map, believe me, it's not a straight line. That drive right there might take 7 hours, sometimes more, sometimes just a little bit less. But one of the things that you encounter along the way is the largest potholes you've ever seen in a road, because some of the roads have been bombed as well. So you might start down one way to get there and have to stop and use your GPS or whatever you can do to find a different way of even finding a road that continues towards Kyiv. Very challenging just to even get there. Along the way, you're going to encounter security. You're going to encounter checkpoints where people are going to ask, why are you here? So you better have some paperwork to show, as me, as an American, why am I suddenly driving in the middle of Ukraine? So you encounter different security. The other issue that's really important about doing anything in Ukraine is how fractional it is. You would think that there would be one central government decision-making power, or it's the Ministry of Defense, Ministry of Finance, or their own DOD. What you find is it's so fractional. You have decision makers from Border Control, Territorial Defense Brigade, National Guard. They just recently, a few months ago, created their own drone army. So when you have multiple different groups that are actually competing with each other on how to get the material that they all want, but I would say it's one country where the right hand and the left hand really aren't speaking to each other a lot. So you're dealing with a lot of different groups that have a lot of different needs that are competing for those same funds to be able to get the equipment or devices or whatever they need. And even among those fractional groups, it's extremely fluid. The needs are changing all the time. Omer mentioned earlier the number of 10,000 drones a month being downed. Actually, the latest numbers that we got is they are losing 2,500 each day. So when you think about a country losing 75,000 drones every month, the ability to backfill that is incredible. But also, it means that they've lost 75,000 drones that didn't complete a mission, and that's a lot of money wasted. So this is why Ukraine is such a market for GPS protection, because you can imagine if those 75,000 actually were protected and achieved a mission, what a difference it would make. The pace. One thing that we noticed all the time is even though you might be meeting with decision makers, decisions are slow. Everybody is always trying to check a box, go through protocols. And I think it's one of the biggest frustrations, even for Ukrainians, is the people on the ground may know what they want, and they want it yesterday. And yet, a lot of times, the decision making and actually procure anything and get it to those front lines, it takes months. Sometimes now, we've been at this over a couple of years, and we're dealing with the same people with different needs, but going through the same procurement and difficulties getting what they need. It's very frustrating for the people on the ground because they tell us all the time, if we had this yesterday, if we had this last week, last month, how many people they could save. The other thing, obviously, you're in a war zone. It's dangerous. If you're not used to air raid sirens, it's the wrong place to be. Air raid sirens are a daily or nightly occurrence. And what's interesting to me, every time I'm there, the Ukrainians are so conditioned to it, they ignore them. But when you're coming from America or another country and trying to do business there, it can be just a little bit unnerving to go to an air raid shelter on a daily basis or nightly basis in the middle of the night. So when you're there, you know you're in a dangerous area. Even though the Ukrainians a lot of times are so used to it, they may say, "Oh, it's safe here. It's safe here." Remember, it's unpredictable. And then there's stability. One of the issues that we always have is the person that's a decision maker that I may be talking to last month might not be in the same position this month. When people are being, I guess, as they're being sacked, and we always hear about corruption in Ukraine, and it's very true. There is corruption in Ukraine, and corruption in Ukraine is one of the reasons why some of the different changes have taken place in the government, in the ministry. But there's a backlash to that. When somebody now replaces somebody who's been sacked for corruption, you can imagine they're just a little more careful, and it takes more time to make a decision because they don't want to be accused of corruption. So making those changes actually has slowed things down in our experience in the decision making and doing business in Ukraine. We find it a great challenge over there that you would not find in any other country probably in the world right now, especially because as you keep mentioning about Russia being such a source of a lot of this jamming, well, you know, you're right along the border, as you can see, of the source of it all. So it's a challenging environment. We know that a device that you were talking about, Omer, about the device that can be put onto a drone, we know that it can have an impact for sure. Our experience has been in Eastern Europe with you so far, but we know that the technology is there, but we know, like we said, it's fluid, and the changes and the needs. Once you think you have something protected, somebody else is working. The bad guys, as Dana just said, are always working on another way to take you down. So I hope that was just a little bit of information about the challenges in Ukraine, and happy to take any questions as I battle through this. Thank you.
Thank you, Jeff. It's a very interesting and eye-opening experience dealing with Ukraine. So not only the GPS, GNSS issues are compromised there, but a lot more. So I'm sure we'll hear more about this during the Q&A session. Okay, let's move on. I invite Ofer Rubin, Heven's Drones Chief Technology Officer, to share some of his operational experience, primarily in our region in the Middle East. Ofer, please.
Hi, everyone. Thank you very much for joining us. It's a pleasure to be here. Thank you. I will present a little bit about the collaboration between Heven Drones and infiniDome. So first of all, a few things about Heven Drones. This is our team. Our headquarters is in Miami, Florida, and our R&D center is in Israel. Our goal is to create heavy lift, long endurance drones that can do more than the regular drones. This is part of our team here in Israel, and we got more. So let me talk first of all about our roadmap, what are the development map, and then I'm going back to the hydrogen cell. So we started in 2019 working on heavy load electric drones, which can carry more than 30 kilograms. And let's say 2 or 3 years ago, we decided to move on to the hydrogen, okay? Because we are talking about heavy lift and long endurance, we understand, and there is always a factor that we can do between the long endurance, and especially if we are talking about electric or any combustion engines, we know that you need to compromise on your payload once you want to go to long endurance. This is why we decided to go to hydrogen, because as we all know, hydrogen its energy density is very high. It's the highest because this is the smallest molecule on Earth. And this way we can combine those two factors between long endurance and heavy payloads. We started by working on hovering hydrogen drones. We already got those kind of drones. And let's say a year or a year and a half ago, we decided to pivot to the VTOL era, because this is the right way to optimize, let's say, the use of hydrogen on a drone, because some kind of let's say, the limitation that we got from drones. And this is exactly where we are right now. We are in the beginning of the pivot of going to the VTOL hydrogen solution. So why we are going to hydrogen, as I told you, first of all, once we are talking about endurance, we are talking about way longer endurance. One of the other key elements that we got from hydrogen is really, let's say, small IR signature and noise signature. And we are able to even to reduce the logistic state that come from hydrogen, because we can produce hydrogen everywhere. So we don't need to carry a generator or something. We can create hydrogen in the middle of nowhere, and this way we were able to fly our drones. And then, let's say a year ago, October 7th begins, and here in Israel, the era has been changed. It was a terrible day for us, and since then, it's very, very difficult to operate and even develop in Israel. And as Omer and Dana showed you before, here in Israel, we're having all the time spoofing and jamming, and it's everywhere. You cannot rely on drone at all here at Israel, and this is why we decided that we must integrate those infiniDome systems and some other systems as well that can handle GPS denied environment. First of all, it's about modality. Okay, so what we're talking about modality, we must have, because our drones are not the cheapest drone, because still hydrogen drones are a little bit more expensive. So we must validate that our drones are able to operate and to come back to our place. And this modality is not just related to the navigation system, it's related to the propulsion system. Even our drones, our hydrogen hybrid electric drones, are combined with electric motors and battery and hydrogen fuel cells. So we have modality all over the place, even in the perception system, in the, let's say, in the autonomy system, we've got modality, and we decided that we must have modality in our navigation system, and we are not using just infiniDomes. We are using some other techniques as well, like these ones and some other techniques. And we understand that the advantages and disadvantages of each techniques. But we understood that we must validate those techniques and to utilize each technique to the specific, let's say, concepts that it's operating in. And we understood, for example, that In low altitude navigation, there is no solution that is better than infiniDome solutions, okay? Because, for example, for VSLAM, you must be high above texture, let's say visual textures, and you need to be able to optical flow between those textures. And with infiniDome solution, you don't have those kind of requirements in order to navigate in those situations. In addition to that, in Israel, since October 7th, there are no GPS signals as well, and we must keep develop our systems. So there is no way that we were able to continue the development of our system. In the beginning of just after the 7th of October, we had to travel sometimes even 2 hours to a specific location where there is a GPS signals in order to test our new features or something like this. Today, after we integrate infiniDome, we are able to do it everywhere, even next to our. We are located in the north side of Israel, which is pretty jammed all the times and spoofed all the times, and you don't know, in the morning it can be spoofed one way, and in the evening it can be spoofed some other ways, and this is the only way that we are able to keep our development going and to keep our people safe, because we operate heavy lift, heavy drones, which are dangerous, and if the drone don't know where to go, we can go into your pool, which is a safety factor, and we are not able to operate them. And in addition to that, even in the commercial sectors, definitely in the defense sectors, it's become a standard. But as you can see from Omer presentation and Dana presentations today, to spoof or jam, even in the commercial sectors, it's pretty easy. And if you want to be able to operate all the time toward your customers, you must validate that your system can handle any scenario. And today, in today's world, you must take interactions that's jammed or spoofed. It's part of the games, and you need to be able to handle it. And this is why we are trying all the solutions. And we find that infiniDome is one of the best solutions, and definitely one of the leaders in specific operation codes. Thank you, everybody. If you have any question, I will be more than happy to answer. Thank you.
Thank you, Ofer. Thank you very much. It's time to see some action, so let's get our hands dirty. Omer, please show us the presentation, the demonstration.
Sure. I think that Noam will be able to present it, but I just wanted to give a little bit of a background to what we're going to see. So we're going to see Jonathan, one of our senior engineers, in our lab, showing our flagship product, GPS Dome 2, in the face of real jamming and how it copes with it. Then we're going to move for a few minutes to a demonstration in the field on a drone with Dean, our senior field application engineer, also showing the performance of the system live on a drone in the air. So it'll give you a real sense of what this thing can do, not only with numbers floating around, but an actual application in the field.
Hi, my name is Jonathan. I'm one of the development engineers here at infiniDome, and you're joining me here at infiniDome Labs in Caesarea, Israel, to see a demonstration of our GPS Dome 2 system. So let's take a look here on the table. We can see our GPS Dome 2 system. The GPS Dome 2, connected to 4 antennas, can supply protection against 3 simultaneous directions of jamming. So we have our system here connected to 4 antennas, and the output is connected to a splitter, which takes the signal to a GNSS receiver. And in parallel to that, we can see the spectrum analyzer, which shows the output, so we can monitor the jamming signals we're detecting. Alongside our system, we have another reference receiver, the exact same model as the protected receiver, only this one is connected directly to an antenna, unprotected, so we can see how our system gives a good protection to the receiver. So currently in Israel, since the war started, we've been dealing on a daily basis with jamming signals, all different types, all different hours of the day, including now when we're shooting. We actually have jammers here detected by our antennas. If we take a look here at the spectrum analyzer, we are monitoring the 24 megahertz bandwidth of the GPS GNSS signal, and we can see the jammer is a very high power jammer, just about 4 megahertz bandwidth in the center of the GPS signals. If we look here at the screen, we can see two interfaces which show us the data coming from our GNSS receivers. The left window is showing us the protected receiver, and the right screen is showing us the unprotected receiver. Right now, our GPSDome 2 is in a freeze mode. It is not protecting the receiver. That is why we can see both receivers right now have no indication of satellites detected, and we can see in the no fixed indication that they both have no position fixed based on GNSS satellites. I will now activate our protection. And if we take a look here at the spectrum, we can immediately see how the system has attenuated the signal, and now it's stable. It has attenuated it by a big margin. And if we take a look back here at the screen, we can see that the left window, again showing us the protected receiver, is now seeing a whole bunch of GPS satellites, as opposed to the right window unprotected receiver has no satellites because of the jamming signal. And at the fixed indication, we can see that our protected receiver now has a proper 3-dimension position fix with good accuracy. So basically we can see how our system, with a real jammer that we detect here, is producing a good protection to a GNSS receiver, while an unprotected receiver is blind and has no position. Next up, you will be seeing a demonstration of our system deployed on a drone outside in the field.
Hi everyone, Dean here from infiniDome Field Appliance Engineer team, and we are going to show you our infiniDrone experimental drone that we are using is protected against jamming. We are connected to this drone two receiver. One is protected and one is unprotected, and we are going to show you how our solution is still going to work in environment that is full with jamming. So let's go to fly.
First, let's understand what we are seeing on the screen. On the right, we have the map showing the drone marker and the home point. On the left, we have two displays. On the upper screen, we can see inductor showing the drone angle. In the same display, on the left, we see the drone speed, and on the right, we will see the altitude. Additionally, a bit lower, we have two inductors. One showed the GPS reception on our unprotected receiver, the Ear 2, and the GPS 2 showing the reception on the protected receiver with the GPSDome 2. In the lower screen, we'll focus on the sat count, which induct the number of the satellite received by the unprotected system, and the sat count 2, which induct the number of the satellite in the protected system with the GPSDome 2. Okay, let's continue to the flight. Before takeoff, we see the satellite reception of the both receiver because the area we are flying in only has jamming in the altitude. After takeoff, when we are reached to the jamming altitude, the unprotected system starts to lose reception, and the number of the satellite decrease until it reaches almost zero and even to zero on the unprotected receiver. In contrast, in the protected system with the GPSDome 2, there are only slight decrease in the number of the satellite, but the reception remains stable, allow the drone continue navigate even in the area with the multiply jamming. Thank you for joining us for the field experiment in the Israeli airspace. Returning the broadcast to the webinar. Enjoy.
Thank you very much. Omer, any comments before we proceed?
No, just a short, very short comment. At the end of the day, as I said before, we try to help our customers solve their problems. We don't sell a box. We try to help our customers solve our problems, and I'm trying to convince all of our customers, don't trust anybody, don't trust me, don't trust anybody. Test for yourself. Work on building the capability to test in real jamming scenarios, and we will help you do that. So definitely try to do that before going into the field and learning at the moment you least want to, that things don't work.
Yep. Okay, so we've ended the presentations. We'll move now to the question and answers section of our presentation. We have several questions here. Some were addressed directly by the panelists, and others I will read them out loud, and you can address them. So there are some questions about the war in Ukraine, especially what Jeff and Dana have mentioned. So Chris Daniels writes, if I were losing 2,500 drones per day, I'd be readdressing my strategy. Why is it still a valid strategy in Ukraine? What not use a smaller number of hardened drones or something else to achieve their aims? Is there a likely optimal status in the future to this simply or is it simply a case of throwing more drones and more mass at the enemy? It's the right question to address the huge numbers of drones operated and lost. And I think I'll have a follow-up question after this is answered. So who will answer this one? You may read the question in the question and answers panel.
Yeah. I'm happy to jump in on that. I would say that you get what you pay for. And the drones that they're losing are unprotected in a mostly smaller FPV drones that they can make very cheaply in a lot of underground and small factories that they just crank these out, try to put ammunition onto it and fly it. So when you say a valid strategy, I think it all comes down to what you can afford. And they're throwing a lot of mud at the wall to see if they have, say, 5,000 going out a day, maybe 2,500 don't achieve a mission, but maybe the other half do. And yeah, I don't think it's a great strategy, of course, because you would like to see a better success rate. But yeah, you definitely get what you pay for. And what all this is doing is reinforcing that without a protected mechanism device like infiniDome, you're really risking whatever you paid for whatever drone you're using.
I would like to add to this comment. Most of the drones that are expended in the Ukraine and Russian war zone are likely FPV drones that would be lost anyhow. I mean, either they hit the target or they miss the target, but they are one-way drones.
Yes.
The more important ones are the reconnaissance drones that should live to operate on another mission, at least one, and mostly 3. After 3 missions, they are mostly lost due to electronic warfare or something else. So if someone would equip a drone to survive the GNSS challenge or electronic or data link challenge, it will first, there will be the reconnaissance drones, and there would be worth the investment. Another question, a follow-up question I had is from the number of lost drones in Ukraine, what would you think the main cause of the losses are? I think Jeff could address this.
Yes. Well, the main is obviously they're being jammed, and just like you just mentioned, Tamir, a lot of them are one-way drones who just aren't able to reach their target anyway. But yeah, when again, if you're just making a lot of very small hobbyist type of drones that you can buy on Amazon and try to actually use those in a war theater, that's what you're going to find out, that they are not really built for that. You're just trying to use them that way, and that's really the cause of a lot of it. They're using drones that normally would just take pictures of houses for realtors or for kids to play with, at parks, and then trying to use them thinking that they're going to fly towards Russian lines. It just doesn't work that way.
Mm-hmm. Okay. There's another question about the CRPA module. It is directed to Omer. Could you address this one, Omer?
Yeah, sure. So SERPA is the acronym that was always traditionally used. We call it in Hebrew antenna mistageret, or adaptive antenna, which is basically the logic of how to protect the GPS signal at the antenna end. So yes and no, to answer the question. We are implementing some SERPA methodologies, but we're not doing it at the antenna edge. We're doing it at a separate module. One of our advantages is that we can work with off-the-shelf antennas, and we can work with off-the-shelf receivers. We're a module that sort of sits like a filter in between the antenna and the receivers. So it is somewhat similar, but not very much alike the traditional SERPA antennas. That's one of the reasons why we went for this approach, to allow ourselves to be retrofitted and to allow ourselves to be a much smaller form factor, lower price, lower costing solution than what the traditional solutions look like today, which are usually big, heavy, very expensive, very classified solutions.
Here's another question from Itamar Lev2. He asks if there are any effective alternatives to satellite-based GNSS. I think Dana and Omer can address this.
So yes, there are, but they're not available to everyone. A lot of the alternatives, actually, a lot of the wide area alternatives are available in Russia and China because they have terrestrial RAN systems that people can use to navigate and also to get timing on. If you're in an aircraft, flying commercial airliners, for navigation, you can use terrestrial beacons called VORs and DMEs. These were the navigation methods that were used before GPS, and actually LORAN was used before GPS too, before it was shut down in Europe and the United States. Generally, there is no global alternative to GPS or satellite-based navigation. There are lots of technologies available. So magnetic flux, for example, is an interesting way that some folks are beginning to use to navigate. But all of these are, perhaps mature technologies, they're not well distributed and adopted yet. So if if you are a private citizen or a small company or a small nation even, and you would like to wean yourself off of satellite navigation, there aren't a whole lot of near-term alternatives other than just coping and improving your equipment, like with an infiniDome antenna, maybe some better software, all of that depending, of course, on one's budget and how urgent your need is.
Omer, any comments on this issue?
No, I mean, I totally agree with Dana. Just one comment. So we've seen since 2019, we've seen interferences for airplanes coming down to land in Ben Gurion Airport. Obviously, we've seen this more and more since the beginning of the war, but we've seen this also back, 5 years ago. And the interesting thing is that again, it's a manned airplane. It's not going to crash into the ground when it's jammed. When it's spoofed, it might be more dangerous. The cockpit can light up like a Christmas tree because everybody thinks, hey, I'm right now above, going to hit a mountain when I'm actually not there. Obviously, when spoofing is in action. But what they did result to here in Israel is that using, as Dana mentioned, specific systems to, for example, guide the airplane when it's coming down to land, and it's not based on GPS. So there are solutions, very localized, that could be accessible to commercial aerospace, for example. But I think, as we mentioned before, there is no bullet, proof solution. There is no silver bullet that solves everything. And everybody has to think of not if my single thing that I'm counting on that'll work will not work at some point, but what do I do when it doesn't work? Because it's not going to work all the time. So try to think of as many ways as you can to make sure that you're not, caught with your pants down.
There is a question from Nathaniel Davidovich. I think it's connected to what we discussed now. He asks, any word of further work based on computer vision or LiDAR as a complementary or backup method for GPS signal loss? What are the challenges and what an estimated time to market?
So I'll take that. So computer vision is something, terrain matching, map matching, that sort of thing. It's something that's been investigated for quite a while. A lot of people having challenges with that. LiDAR is great. But even when visual navigation systems, automated visual navigation systems are available, they're going to be expensive, as is LiDAR. And you will need to integrate them with maps and then into the systems that these navigation systems are supposed to support. So it's again, there's lots of technology, but it doesn't have what we call beneficial swap C, so size, weight, power, cost, it generally beyond the reach for most folks, and in many instances not, well, technically feasible, not technically practical. Been spoiled by GPS, really, really spoiled by GPS. It's global, you get it on a computer chip, it fits into everything. But then again, we've been working on it for 40 years, right? More longer than 40 years, probably more like 60 years been working on it. It's been fully operational for 40. So, you have to take these things in stride. And the strategy for as Omer said, for individuals is figure out what you're going to do in advance as much as you can for when it's not available. Strategy for the world is make some decisions and figure out where we want to be in 40 or 60 years from now and start getting there, because that's how long it takes for these kinds of really effective navigation and timing systems to be implemented and be adopted. So people have a real challenge in taking the longer view and being able to undertake these long-term projects. But it's something we have to do, and I hope we get started soon.
Thank you. And we have several questions about some of the techniques and technologies upcoming to the market. Giovanni Jimenez asks about any estimates when will M-code constellations will be deployed, and any plans for M-code receivers being capable of spot mode.
Well, I guess I should answer that, probably being a bit more familiar. So M-code is specifically for the U.S. Department of Defense military and U.S. military forces and the military forces of selected allies. As someone, I think in the chat or in the Q&A indicated, it's, or maybe Omer said, but it's not, again, it's not a silver bullet, right? It can be jammed. It's a little bit more difficult than being jammed. It can also be meconned, right? So meconning is kind of like spoofing. It's where the adversary copies the entire signal from the satellite and then rebroadcasts it someplace else. So you don't have to know what the code is coming down from the signal. You just need to be able to copy it and then rebroadcast it and confuse the receiver to think, oh, it's coming from over there in a different time, and I need to, I'm really not where I am or when I am. So part of the challenge with M-code is the activation of the new ground control system for GPS, and there are other issues there as well that we don't need to get into. But it is relatively, well, it's not brand new technology. M-code was developed in the year 2000, or maybe a bit before. So it gives you an idea as to how long it's been around and how fresh some of the associated technology might be. So no, that's a long bureaucratic answer. Saying it's you can't overcome your past. To the short answer, which is not really. We really don't know when it's going to be available fully, right? Although folks are starting to use it now in some instances.
Yeah. Another question from Bruno. Kai Mulshay, maybe I'm not pronouncing the name correctly, but his question regards the frequency bands. Which frequency of GNSS is highly affected? How are the signals L1C, L2C, and L5 performing in the war zone? And he also addresses the issue of ionospheric irregularities in the jamming time. So how they affect, how natural phenomena affects the jamming and the interference. Omer, I see you are.
Yeah. So I'll be happy to take the first one. If Dana, you can take the second one. So talking about what interferences we're seeing in war zones, I can vouch for what we're seeing here in Israel. I have less experience and less knowledge of what happens in other conflict zones. So what we're seeing here is basically the entire spectrum is under attack. Obviously not equally so. The most popular signal that is being constantly attacked is the L1 band, which includes L1C, of course. But we are seeing that in areas you simply can't trust any band to be available and harmless anymore. So to answer your question, we're seeing all bands being challenged, even L5, but some more than others. So yes, I think that using a multiple band receiver is the right approach, and it might get you 95% of the way. But for that extra 5%, you're going to need protection and alternative solutions as well.
Right, and as far as the sun and other natural phenomena, yeah, it's a challenge. To date, hasn't been a big concern. Of course, we are approaching solar maximum in June or July of 2025, so we expect an increasing amount of activity. But even with all of the activity we've seen so far this year, northern lights coming down quite south, there hasn't been that much impact on GPS services. Now, earlier in the springtime, a number of U.S. farmers had to stop planting for a weekend because there was enough wiggle and interference with their equipment that they couldn't do the precision agriculture that they needed to do. So we don't really know what the economic fallout of that has been as we're approaching finishing up the harvest season, but it was an impact. The big concern, I think, for most people is a serious coronal mass ejection that could ionize the atmosphere and prevent signals from space, certainly from GNSS satellites, from getting to Earth from over the course of a day or perhaps even a week, or even a stronger incident that could damage or destroy satellites. Not beyond the realm of possibility. It's a very small percentage a risk each year, but as the years go by, as you're looking over a longer period of time, the cumulative risk becomes substantial. So it's probably one of those things. It's not a matter of if, but when. When could be tomorrow, or it could be 150 years from now. We don't know.
Okay, that's I have one question from here, from the podium. Is it possible to use ground-based nodes or pseudo satellites in a small country like Israel or Liechtenstein or Latvia to augment this problem and give the systems some resiliency?
No. Most if you're talking about augmenting the satellites and doing something to make the satellite systems more resilient, I would say pretty much no. Now, if you are talking about establishing a local navigation system for use when GPS and other GNSS satellites are available, yes, I think that's fairly accessible to pretty much every nation. And in fact, we advocate for each nation to have their own terrestrial sovereign navigation system, navigation and timing, because timing is very important. And we get that from GPS and GNSS as well. And it can be as few as 3 towers, right? To be able to give you that kind of resilience. And so you would be able to cooperate with the great powers and receive Beidou and GLONASS and Galileo and GPS and use all that. And when it was available, everything would be fine. But when people started messing with it, or if the great powers started messing with each other, then you would have your own terrestrial system that was integrated in receivers with satellite navigation, and you would have that as an alternative. I wouldn't say backup, because they would operate. We would advocate that they all operate all the time. And in fact, if your country had those 3 towers, you would probably find less interruption with GPS signals in your country, because malicious folks, why would they bother to interrupt it if they knew that all of your citizens, or at least most of your critical infrastructure, wasn't going to be affected because they had an alternative? So you'd actually be not only making your citizens and infrastructure safer, but you'd be making the satellite navigation signal safer, because they'd be under less threat.
Thank you.
Mm-hmm.
So now, sorry. So we've ended our webinar. We've ended and addressed quite a few questions. So the topic is important, interesting, and intriguing. And now it's time to wrap up. As we conclude this event, I want to express my sincere gratitude to our expert panelists and our host, infiniDome, for making this discussion possible. Thank you all for your active participation, and most of you I see have stayed with us till the end, so thank you very much, our audience. And we look forward to seeing you at the future events. I remind you that the recording of the presentation and the webinar will be available on infiniDome's digital channels. So feel free to visit and attend it again and rehear the important parts that you feel you want to see. Thank you very much, and best of health for all of you. I see quite a few of us are coughing or sore throats, so we'll survive. Thank you very much, and we'll wrap it up here. Bye-bye.
Very good.
Thank you
Bye-bye.
very much, everybody.
Thank you. Bye-bye.